Alright. Hari tu apa? A ke B? Kedua. So, sebabnya Aiman yang tak main kan? So, kita dengan tak lagi lah. Right, Madrid? Okay. We are a team. We always are a team. When we go down together. When we go up together. So, when your friend didn't come, you plan everything. But here, you just say it. All the 5 factors affecting rate of reaction. Surface area. Particle size. Tak ada. Apa lagi tanya kawan dia? Apa lagi tak masuk dalam faktor saya? Catalyst. Satu kelas sendiri. Pressure. Betul? Yes. I mean it. Thank you. Sehingga saya tanya semua soalan dan kamu boleh jawab hari ini. Okay. So, the 5 factor that we are talking about, all the 5, dan kalau kamu perasan in our syllabus, in your lab, kita tak buat pressure and volume, betul? Pressure and volume kita tak buat sebab dia mesti hanya melibatkan gas. So, saya nak sambung deeper on top of that day. Your concentration, kita hanya boleh bermain about gas and aqueous. Particle size only apply to solid. Your pressure and volume only apply to gas. Okay? And temperature can apply in everything. Catalyst also can be applied in everything. Depends on the reaction, whether will be affected by the catalyst or not. Ada reaction yang kamu tambah catalyst pun dia tak akan buat apa sebab dia tak affected by that catalyst. Okay? So depends lah, tapi kita tak belajar deep about catalyst, don't worry. Yang kita belajar banyak adalah yang dia akan memainkan peranan is your concentration that will only take count of your gas aqueous. Surface area only solid, pressure and volume only gas. And that's why we are not doing pressure and volume in the lab. Okay, sebab gas bahaya lah. Okay, as we all agree, we have 2 sentences in your explanation that is the same. Okay, so before I move on, your concentration over here is directly proportional to the rate. So when the concentration increase, the rate increase. Agree? Okay. So in concentration, the sentence that you really need to remember, ayat yang kamu kena ingat betul-betul is only this. More particles of a reactant are present in the same volume. Okay? Itu sahaja. Because in every single factor, you realize that ayat bawah dua tu sama. Betul? So, 2 ayat yang bawah tu sama adalah apa? Collision increase, effective collision increase. So, your thinking should be going towards why the collision increase. Why when the concentration increase, the collision increase. Don't memorize by heart. Understand, then your life is easy. So, setiap kali bila kamu tengok faktor, kamu kena tanya diri kamu, kenapa collision akan bertambah? Kenapa pelanggaran akan bertambah? I have 113 of you in this lecture hall. Okay? And how do I increase the collision if I force you to run around in this lecture hall? One way to increase the collision, I bring in another group of people. Betul? Alright? Or I decrease the size. I bring you to a smaller room. Betul? Can you see that? So, the things that you need to think of is why concentration will increase the collision. Because the number of particles per volume, per same volume. Alright? In the same volume, the number of particles increase. So, bayangkan kamu ada kat sini 113 and then I bring 113 of you pergi ke Padang, ke Astaka. Lepas tu saya bawa another group of people juga. Okay? Is the collision will increase? No. I have the same group of people but I change the volume. Alright? I bring this group of people, saya tambah orang. Yes, concentration increase but my volume increase. Betul? So, kamu takkan melanggar juga. Make sense? So, constant volume must be that. Okay, the number of particles increase in the same volume. That's why the collision increase. That's why the effective collision increase. Same thing. Surface area and particle size the other day. Siapa nak jawab? Okay, first question. Particle size and surface area, their relationship. They are inversely proportional. Betul? So, particle size increase. Kalau particle size besar, bermakna surface area kita kecil. Garam kasar dengan garam halus on the last Saturday, remember? Okay, look at it. The same thing, sayang. Saya nak frequency of collision increase. Macam mana dia boleh berlanggar dengan lebih banyak? Obviously, when the surface area is bigger. Betul? Bila permukaan yang kita ada lebih besar, dan dia akan melanggar lebih banyak. Daging. Pernah masak daging? Okay. Kalau saya masak daging seketul sekilo, alright, dengan saya potong. Siapa lagi cepat masak? Kenapa yang potong lagi cepat masak? Right? The particle size is smaller. When the particle size is smaller, the surface area is larger. So when the surface area is larger, permukaan lebih banyak untuk dilanggar. Alright, when the larger the surface area, more collision, higher effective collision rate of fraction increase. So saya tak nak kamu hafal, just hafal sebab misong so hafal. Don't do that. Ask yourself, why the collision increase? Okay, that is the reason why you need to memorize. Sayang, dengan kata lain, you only need to know this. Sebab ayat 2 ni sama. Ayat ni sama. Betul? So, jangan kata satu faktor kena hafal banyak lah. Satu faktor hafal satu ayat je weh. Nampak? Okay, satu faktor hanya hafal satu ayat. Pressure, volume. Okay, kat sini. We are changing the pressure and volume. Next question. Pressure and volume relationship. Go. Inversely proportional. Pressure increase, volume decrease. Tengok Squid Game? Squid Game. Girl can sit. Alright. And I love that. I love everything that I do in the lecture to keep you awake. Okay? And kalau dulu tak ada COVID, I'll be walking around, up and down. Sebab tu saya boleh tak pakai mic. Tapi sekarang sebab I cannot go near to you, then we have Squid Game. Jahat aku. Alright, pressure and volume. Remember the story of you and the group of people to the field. Betul? Right now, tak ada concentration. Factor concentration is not involved. Only you. So in here, in this volume or in the field, alright, kat padang, which way or which condition that you will be colliding with your friend more? In here or in the field? Why? Volume is small. When the volume is small, alright, when the volume is small, kamu akan berjumpa lebih kerap. Betul? So you'll be colliding each other more frequent. Nampak? So dia nak kata hafal, I don't think you really need to memorize. You only need to know one thing is, if I want the rate of fraction increase, saya nak benda tu berlaku cepat, bermakna dia kena berlanggar dengan banyak. Macam mana saya boleh berlanggar dengan banyak? Kawasan yang luas atau kawasan yang kecil? Obviously, kawasan yang kecil. Betul? Macam mana kawasan saya boleh jadi kecil? Pressure. Betul? Alright, macam mana kawasan saya boleh jadi kecil? Pressure. Right? So, kamu tekan dia, dia akan jadi kecil. Right? When you press, you put pressure on it, then the volume will decrease. That's why, when the pressure increase, the volume will decrease. Betul? Okay. Sebelum saya move on, the next one I think on my slide adalah catalyst. Ladies and gentlemen, catalyst. Anybody can tell me what is the function of catalyst? Provide alternative pathway je. Belakang dulu. Ya, belakang. Yuk. Yang gelap tu, yuk. Yang tengok belakang tu, ha?
Provide alternative pathway to lower the activation energy.
Okay. English kat sini. Muatkan dulu ni. Alright, let's play a bit about English. Kan belum muat? Dah buat belum? Belum. Alright, how many times you're getting back 10? Alright, Azim said just now, I repeat exactly what Azim said. Okay? Provide an alternative pathway to lower the activation energy. Yes or no? Why not? Okay, to provide to lower the activation energy, dia tidak akan merendahkan activation energy. Kalau activation energy adalah 100, dia akan bukan 100. Kita tak boleh rendahkan activation energy tu. Apa yang kita buat? Kita buat jalan baru, kita bagi activation energy yang baru. Provide an alternative pathway. Alright, boleh duduk. Provide an alternative pathway with a lower activation energy. Macam mana aku nak buat? Tak adalah. Saya dulu pun, I got band 4 for the first time. And then it's 3 more marks before band 5. And obviously saya sangat tak puas hati lah. So I took second math just to get band 5. And in the second math, there is 1 more mark to band 5. And I hate math from my life. Okay, catalyst. What are we doing over here? A bit of English. Sebab bila kamu kata to lower the activation energy, salah dah. Kamu kena ingat satu. Activation energy takkan rendah. Kalau dia 100, dia akan kekal 100. Kita tak boleh rendahkan dia. Apa yang kita boleh buat? Kita buat jalan baru. Sebab tu jalan lama tetap ada bila kita ada highway. Betul? Alright, kita hanya buat jalan baru. We provide an alternative pathway with a lower activation energy. Keadaan yang sangat senang. Sekarang nak dapat A 80. Okay, so dalam kuliah saya 113 orang. Mungkin 100 orang akan dapat A lah. Right? Awak hampa masuk kuliah saya dapat B je ke? Dan I only give B effort lah. B effort is baca slide. C effort is buka slide tak buat apa. And I'm doing none of that. Okay? So, kalau sekarang nak dapat A adalah 80. And I'm looking very positive to you. Sekarang with 80, 100 people will get A. What happen if I lower the grade? Saya kata 70 dah dapat A. More people will get A or less people will get A? Same thing. Activation energy is this high. So, bilangan reactant yang akan sampai activation energy dan bergolek turun jadi produk is probably 50%. But what happens when I provide a lower activation energy? More reactant will overcome the activation energy. Betul? More reactant will have the kinetic energy. Okay, obviously we are not talking about mass. There will be the number of molecule having kinetic energy equal or more than will increase. Okay, bilangan molekul yang lebih atau lebih atau sama dengan activation energy will definitely increase. I don't want you to memorize by heart, please. Kalau saya nak kamu hafal, saya tunjuk je, saya suruh hafal. Okay, alright. Budak selalu tak suka explanation. Benda ni keluar tiap-tiap tahun. Rugi kalau tak boleh jawab. Okay, 5 faktor ni dia akan keluar tiap-tiap tahun. Yang mana je? Temperature antara yang favorite kita akan tengok sebab temperature ada graph, ada calculation. Dia antara yang panjang. Okay, so yang belakang tu samalah. Kita nak bergerak kepada temperature. Next question. Temperature. Recap a bit about last week. Exothermic. Delta H. Sorry. Negative. Dia tak akan lebih kat sini lah. Y negative. Negative, betul. Next question, why negative? What?
The energy of the product is bigger than the energy.
The energy of the product is bigger than the energy of the reactant. Setuju?
No. Terbalik.
Terbalik, saya terbalik.
Jawapan.
Jawapan kamu terbalik. So what's the correct answer?
Negative is because the energy of the product is lower than the energy of the reactant.
Setuju mas? Product lower than reactant. Okay. Why product lower than reactant dia akan jadi negative? What is the formula to calculate the delta H? The delta H product, the total of the H product yang kita akan tengok nanti dalam topik itu in few more minutes. Okay. Delta H product minus delta H reactant kena sama dengan negative. That's why your reactant need to be higher than the product just now. Betul? Kita nak negative. Okay. Next, last question yang kamu selalu boleh dulu. Next yang next tak biasa saya tunjuk kali nama where we are? Last but not least, delta H negative in terms of calculation, in terms of value is about all that. Betul? In terms of concept, what the negative represent? Okay. Yes. Energy is being released by who to who? Kita belajar semester 1 topik banyak. From the system to the surrounding. Why are you not wearing pouches? Even though I don't care, but because you die. Alright, I don't really care. So if you wear something, I don't really mind what you wear. But nice lah, jangan masuk dengan kain belikat. Saya tengah podcast malam, aku dah lagi tu masuk dengan kain belikat. Aku tak tahu nak cakap apa sebab saya selalu akan dengar kat budak pakai lah. Aku pun tapi dia pakai semua aku pun. Jangan macam tu saya sayang. Okay, be nice to yourself. Okay. Alright, that is all about temperature, about exo and endo, and therefore endothermic will be the vice versa. Betul? So the vice versa is easy lah. Next question. Delta H for endothermic. Belakang voice Mas Biru. Yes. Positive. Sebelah ya. Y positive. Saya duduk. Go. Fine. The energy of the product is higher than the energy of reactant. Agree? The total energy of the product is higher than the total energy of the reactant. Well done. Right? Last but not least, why, in terms of concept, why is that positive? Or is that this by everybody? Yes. I don't like that answer. No?
Object absorb the energy from the.
I repeat, absorb. We don't have object in chemistry. Have I ever used the word object? System absorb the heat from the surrounding. Thank you. Alright, agree guys? Dan kita akan banyak bincang pasal suhu and in temperature, tak ada apa nak cakap kat sini. Kalau kamu perasan kenapa saya letak temperature and catalyst duduk sekali, both of them are still talking about kinetic energy and activation energy. Do you realize that? Alright, dua-dua adalah cerita pasal energy. Satu perkataan yang saya sangat-sangat insist dan saya nak dalam explanation kamu, average kinetic energy. Pernah masak Maggi? Okay, pernah masak air? Baru masak Maggi atau guna air kowe je ni? Tak tahu periuk? Tahu dapur gas boleh buka? Okay, perfect. Bila kamu masak air, okay, api duduk bawah, betul? Rasa-rasa air kat bawah yang akan panas dulu ke air yang atas panas dulu? Bawah, betul? And what makes pressure cooker is good or what makes air fryer is good because they have air circulation that make the temperature become constant all over the place. Sebab tu dia cepat. Okay? But bila kamu buat cara tradisional lah, balik kampung nak raya nanti kan, nak masak rendang, kita guna api yang kat bawah. So obviously kena gaul. Sebab apa kena gaul? Because we want the heat to transfer up. Betul? Okay, same thing. Kinetic energy tak boleh hanya guna perkataan kinetic energy because if I have a beaker and I heat up the beaker, molekul yang duduk bawah yang akan panas. Molekul duduk atas panas juga tapi slow, betul? So, what makes the kinetic energy different? Kinetic energy adalah setiap orang punya. Average kinetic energy adalah semua orang punya. Okay? Dan kalau saya nak benda tu mendidih, adakah air yang kat bawah dah panas dah boleh didih? Tak. Semua orang kena panas baru boleh didih. Average kinetic energy. Cannot just use kinetic energy. Clear? Well, kita tak bagi makan. Saya insist sebab kita tak bagi makan. Okay? So, the word average kinetic energy is a must. So, when the average kinetic energy of the particle increase already, automatically kalau maka orang kata average call what in the end? Oh, purata. Yes. Kalau maka purata semua dah tinggi, bermakna bilangan A pun automatically akan jadi tinggi lah. Betul? Same thing. If the average kinetic energy is already high, that means there is a lot of molecule can overcome the activation energy. Agree? Simple. Nampak? Alright. Ayat tu tengoklah. Saya takkan baca lah ayat tu. Ayat tu yang saya bagi saya rasa yang paling simple dah. At least I make it the same at the bottom. Okay? So jangan kata kat saya every single factor kena hafal 4 ayat. No. Every single factor 1 or 2 sentence only. Clear? Make sense? Okay. Next. Kita nak tengok yang ni sikit. Alright, this one I want you to pay a bit of attention. Okay, just a bit of attention. First and foremost, this one is compare temperature. Okay, so when we compare temperature, the next thing that you want to look at is kita kena tengok siapa suhu tinggi, siapa suhu rendah. You need to label. Okay, so in this case, my T2 is higher than T1. For example, T2, 200 Kelvin. T1, 100 Kelvin. Just to make your life easier, so I give you value. Okay? Agree, ah? Kita tengok effect of temperature, so kita nak suhu lain lah. So next, we are moving into your graph. Moving into your graph, first and foremost, class, look at the axis. I have number of molecule on your Y. Your X is your energy in kilojoule. Okay? So, number of molecule means the area under the curve. Let's use this one. Katakan yang ni sejuk, T1. T1 saya adalah warna hijau. So, this is my curve of my T1. The area under the curve means everything under the line. This is what we call area under the curve. And the area under the curve for T1 is all this. Agree? Okay? And what is the area under the curve stand for? The area under the curve over here represent the number of particles, number of molecule, boleh. Okay? Alright? Okay? And sayang, kita cerita pasal effect of temperature. Setuju? Concentration sama tak? Sama. You know what happened actually? I have beaker A with the same thing. I have beaker B with exactly the same thing. Kalau pacik ni 1 molar, pacik ni 1 molar, exactly the same thing, but I put at different temperature. Okay? Kalau concentration sama, bilangan particles mesti? Thank you. Therefore, if I say the area under the curve right now represent the number of particles, my question next, what? The area under the curve for T2, the area under the curve for T2 will be bigger than T1, smaller than T1, or equal to T1. Kenapa equal? Sebab concentration sama. Concentration tak berubah, betul? Concentration sama. Bila concentration sama, ladies and gentlemen, that means the area under the curve, total area under the curve for T1 and T2 is the same. Okay? Because concentration is the same. Bila concentration sama, alright, area under the curve akan sama. Make sense? Setuju Sebab tu satu tinggi, kurus. Sebab tu satu gemuk tapi pendek. Okay? Sebab area under the curve sebenarnya adalah sama. First thing. Get it? Second, kita nak tengok effect of temperature, betul? So, suhu bertambah. Orang yang akan jadi product is the area after the activation energy. The one that will become product is the one that after this line. If the molecule can go over the activation energy, then only it can become product. Ingat? EA, tinggi kan? EA duduk atas, betul? So, reactant saya kena naik tangga, baru golek turun bawah. So, apa-apa yang lebih daripada activation energy, baru dia jadi produk. Agree? Perfect. Kalau agree, fikir logik. Suhu and rate of reaction. Suhu tinggi, rate tinggi atau suhu tinggi, rate rendah? Suhu tinggi, rate tinggi. So, kita tengok suhu tinggi terlebih dahulu. Kita tukar color sikit. Suhu tinggi saya adalah T2, which is 200 Kelvin. And this is the curve of T2. And the area under the curve for T2 adalah everything until the x-axis. Everything. Semua ni adalah area under the curve for T2. Agree? Setuju Big, right? Big means what? Area under the curve represent molecule. Betul? Big means more molecule achieve the activation energy. Nampak? Nampak seorang lagi, dia bila ada seorang je dia tak nampak lah bila kita ada orang kedua. Warna hijau saya. Okay, kita tengok balik T1 saya. So T1 saya curve ni. Alright, T1 saya curve ni, betul? So area under the curve saya kat mana? Area under the curve saya adalah daripada curve dia sampai kat bawah. Nampak? Nampak? Sini kan? Setuju tak? So, area under the curve untuk T1 kecil ni je. Area the curve under T2 besar ni. Agree with our concept? The higher the temperature, the higher the rate of reaction. Why? Because more molecule achieve the kinetic energy with higher or equal than activation energy. So, T2 yang tinggi tu kena ada kawasan bawah graf yang lebih besar. Nampak? Itu je dia nak cakap. Alright, itu sahaja dia nak cakap dalam Maxwell-Boltzmann distribution curve. Apa maksud Maxwell-Boltzmann? Obviously pakcik tu lah. You can name your son Muhammad Maxwell and Muhammad Boltzmann. At least next time when they're learning chemistry, they know how to spell the name correctly. Okay, at least you got 1 mark for this. Alright, yalah, daripada Muhammad Daniel Aiman patut tak masuk kelas saya. Guys, duduk semua. Okay, so where we are? Okay, so in the Maxwell-Boltzmann distribution curve, what are we distributing? We are distributing the particles with the kinetic energy. Suhu pula. Energy kat sini paling rendah, betul? Energy kat sini paling rendah lah. Rendah, energy rendah kat sini sikit lah. Betul, sikit, tak ada apa. Kat sini, tengah-tengah. Peak tengah-tengah. Peak tengah-tengah. What the? Sorry. I think it's the setting of this laptop. So dia detect click. So tak boleh nak bowl lah. So, tengah-tengah ni adalah average kinetic energy. Tengah-tengah ni adalah average kinetic energy. Balik kepada teori yang kita belajar. T1 dengan T2. Ingat ya, sekarang T2 saya lebih tinggi. Alright? Suhu lebih tinggi, average kinetic energy lebih tinggi atau lebih rendah? Lebih tinggi, betul? So, kalau saya lukis my Maxwell distribution curve like this, logik tak? Just question. Okay. Boleh tak average dia sama? Boleh tak average dia sama? Kenapa tak boleh? Sebab suhu lain, betul? Katakan kalau suhu yang ni, temperature yang ni adalah 200 Kelvin, temperature yang ni mungkin adalah 400 Kelvin ataupun 500 Kelvin, betul? Kalau suhu dia tinggi, the average kinetic energy of this must be a lot higher. Agree? So bila dia a lot higher when you draw, I teach because you need to draw. Okay, I teach because you need to draw in the exam. Among the favorite questions where you need to draw the Maxwell-Boltzmann distribution curve. So bila kamu lukis, the T1 start kat bawah, kurus, tinggi, turun. Okay, kurus, tinggi, turun. Tak payah, dia everything will be on the left. Everything will lean towards the left. Next, tinggi, temperature yang tinggi, yang gemuk dan pendek. It will lean on the right sebab dia akan tenaga tinggi. So dia akan mula bawah daripada curve ni, naik. Nampak? Puncak tak boleh duduk sekali. Bahasa senang dia, puncak tak boleh duduk sekali. Okay? Nampak? Yang tu yang selalu budak akan salah lah. Okay? Puncak tak boleh duduk sekali. Okay? Make sure the peak is at different position. Make sure the one that having higher temperature, having a higher kinetic energy, average kinetic energy. Okay? Make sense? And last but not least, activation energy nak duduk mana? Activation energy mesti kena duduk bila dua-dua curve dah start landai. Activation energy tak boleh duduk kat sini. Okay? Activation energy kena duduk bila dua-dua curve dah start landai. That only is your EA. Okay? Tu tempat-tempat yang selalu student buat salah lah bila lukis. So pay attention on that. Okay? Question? Oh, last. Tak boleh sentuh paksi X. Bila kamu tengok online, dia banyak yang sentuh paksi X. Tak boleh sentuh paksi X. Kita takkan ada molekul yang tak ada tenaga. Okay? There will be no molecule, no matter how slow the molecule is moving, there will be no molecule that have zero energy. Is that clear? So, dia tak boleh sentuh paksi X. Okay? Dia boleh duduk rapat tapi tak boleh sentuh. Tak ada. Itu je. Okay? Boleh buat? Senang. Okay. Alright. Next. Oh, yang ni kita go through sahaja. Tak ada calculation di tutorial. Okay. Like I promised, a fact of temperature will be the longest. With Maxwell distribution curve that you need to draw and explain. Another one. The only one factor that have calculation. Temperature. So rasa temperature keluar tak? Dan kalau temperature akan keluar untuk calculation dan graph, kalau dia keluar graph means dia akan suruh explain juga. Kalau dia dah keluar untuk calculation, mungkin soalan di bawah tu adalah tanya, suggest another factor to increase the rate of reaction. See the trend of the question? Factor affecting rate of reaction mesti akan keluar every year. Tak pernah tak keluar. Faktor mana je yang nak keluar. Okay? And obviously temperature is one of it. Alright, among the favorite. So, Arrhenius equation. Kalau soalan tanya Arrhenius equation, the exact Arrhenius equation is this one. This is the real Arrhenius equation. Okay? Where your K is your rate of reaction, rate constant. Your K over here is rate constant. Standard rate constant yang kita belajar. Your A is a collision frequency factor, banyak mana kamu berlanggar. The higher the A, the higher the collision. Biasanya dia akan bagi. Dia pernah keluar setahun atau 2 tahun kot, pernah keluar sekali atau 2 kali, dia suruh kira. Tak ada isu, kira je. Tak payah letak unit sebab kamu tak belajar unit dia. Okay? And E is exponent, standard. E pun tak tahu. Do you know exponent? Exponent. Okay? Activation energy is the EA. I write carefully on the formula. Your K is actually your A, E exponent to the power of negative EA over RT. This thing is actually the power of the exponent. Okay, tengok betul-betul lah. Dia bukan darab, tak ada typo, tak ada apa kat situ. Alright. Kat sini ada salah sikit kat nota saya. Siapa yang print nota saya ataupun siapa yang tengok nota kamu, boleh check benda ni. Your activation energy must be in joule per mole. Your activation energy must be in joule per mole. When you substitute in your value, your activation energy must be in joule per mole. Everybody knows that activation energy suka bagi dalam kilojoule, betul? And change that. Itu je yang saya nak tekankan. Among the favorite yang student akan suka salah, calculation dia tak susah. Dia akan bagi semua. Alright, calculation ni tahu apa yang susah? Unit. Sebab suhu kena dalam Kelvin, EA kena dalam joule per mole. Dan kita akan sentiasa bagi dalam degree Celsius and kilojoule per mole. Make sense? The calculation is simple. So be careful. Your R is a gas constant with 8.314. Standard is the constant. Next thing that I want you to pay attention on the unit is your temperature. Your temperature must be in Kelvin. So like I say, yang akan selalu buat salah adalah activation energy kena dalam joule per mole. Temperature kena dalam Kelvin. Then your calculation is easy. Oh, of course, press that calculator correctly. Alright, that's it. That is another story. Okay, lain kali sebelum masuk matrik, kita kena ada test calculator. Test tekan calculator. Okay, bukan calculator. Okay, and that is the real Arrhenius. Kalau soalan tanya Arrhenius, there is a lot of confusion because to be honest, we are not going to use this equation ever. Alright, tahu kan? We are not going to use it. Kita akan guna yang lain. Betul? Kalau kita tak guna dia, tapi soalan suka tanya state Arrhenius equation. You cannot write the ln K that you use. This is your Arrhenius equation. Okay, jangan salah. Okay, but it's very hard to calculate when it's exponent. So what we do when it's very hard to calculate exponent, we cancel off the exponent by ln everything. Sebab tu kita akan ada daripada your K equals to AE negative EA over RT, kita ln everything. So apa yang berlaku, kita dapat ln K equals to your ln A. Power dah cancel off dah, exponent dengan ln dah cancel off. Sebab tu dia jadi tolak EA over R1 over T. And the biggest problem over here is unit. R is a constant of 8.314. Pakcik ni jangan lupa joule per mole. Pakcik ni jangan lupa temperature in Kelvin. Betul? Tapi kat formula ni, can we use this formula? What is the time that we use this formula? Bagi tips sikit lah. When is the time that we use this formula and this formula? Bila masa guna yang atas, bila masa guna yang bawah? Activation sama, R sama, temperature sama. Anyone? Yes. Remember we talk about effect of temperature right now? Effect of temperature means saya ada dua beaker exactly the same content. Saya ada asid 1 molar, saya ada asid 1 molar, betul? Exactly the same content, tapi satu letak dalam ais, satu kita panaskan. That is what we call effect of temperature with the same content. Agree? So, same content, different temperature. Different temperature means satu suhu tu nampak beza tak? Kalau satu suhu, nampak beza tak? Alright? Kamu tahu sekarang sejuk sebab kat luar panas gila. Betul? Alright? Make sense? So, kalau nak cari factor affecting rate of reaction by using temperature, ada dua suhu. Formula atas, formula bawah. Bila masa nak guna formula atas, bila masa nak guna formula bawah depends pada soalan. Kalau soalan tu ada two conditions, alright, low temperature, high temperature lah, biasanya lah, that is our condition, betul? Formula ni kita akan guna. Agree? Okay? Kalau soalan tu hanya ada satu condition, dia boleh akan ada satu condition. Soalan boleh mula dengan satu condition di mana soalan ni dia boleh minta cari K yang kamu tak ada. Dia boleh minta cari A yang kamu tak ada. Ataupun soalan ni, oh God, how do I stop this? Okay. Ataupun soalan kamu dia keluar tapi dia tak bagi EA. Nampak tak? Padahal kita nak gunakan EA kat atas. So macam mana kita buat? Kita cari dulu EA by using this formula. Nampak? And the main difference in atas dengan bawah is when you only have one condition. You only need one temperature, one condition, then you find the rest of the thing. Okay? Atas is when you're comparing two different temperature. So ada panas, ada sejuk, ada ikutlah. Alright? Makes sense? Okay? Boleh? And sayang, satu je. Unit, and tekan calculator betul-betul. If HIV is horrible 10 years ago, HIV is almost curable nowadays. Alright? HIV is not something that people ask. I mean, don't look at people that are having HIV and then you feel that it's something because it's almost curable. Of course, it's not a good thing, so don't get it. But what I'm trying to say over here, if HIV is horrible, student saya salah tekan calculator lagi terrible. You don't even know where you get that from. You know? Apa punya skill tekan calculator tu. Kalau saya takut COVID, saya takut lagi budak saya salah tekan calculator dalam kelas. Sayang, tekan calculator betul-betul. Alright, it's a long formula, so the only thing that I really hope is tekan calculator betul-betul. Okay? And it's a simple formula over there. Makes sense? Okay, ada soalan? Tak ada. So far, happy with that? Because you are coming to the end of your topic 1. I'm sorry, I really don't have time for the example, so I only teach you the basic. If you have any question that you cannot do, you can PM me or you can find me in the office. Then we can do it. Okay? Soalan setakat ni? Nope, happy? Ampa happy je sehingga saya panggil. Alright, just very quick one because I will leave you with some work. Before I come back next week, kalau Daniel Aiman tak datang lagi, jangan sampai kena lagi lah. Because next week, we have a lot more questions to ask. Because going into your topic 2, alright, going into your topic 2, a bit 10 minutes only, okay? Sebab saya nak ajar saja, saya nak kamu balik baca sendiri. Your topic 2 over here, we have 4 subtopic, okay? We have 4 subtopic. Subtopic 2.1 adalah theory, basic theory. Semua ni adalah calculation. But, there's always a but, right? Alright, but whenever it's a but, it's not a good thing behind that. Okay? Yeah, that is what we call sandwich theory. We give you the bread, we give you the filling, and then we give you another bread. So, the but is, if you don't understand your 2.1 theory, you cannot calculate anything down there. You have almost 8 definition to memorize. Kalau siapa yang dah baca, you have your standard enthalpy of combustion, standard enthalpy of neutralization, betul. Enthalpy of atomization, pernah dengar semua tu? Alright, and duka cita dimaklumkan. You need to be able to memorize the sentence and write the equation. If you cannot do it for that enthalpy, 2.2, 2.3, 2.4, bye-bye. You cannot do any of those. Semua tu adalah bergantung pada 2.1 kita. Okay? So, very first thing in your 2.1, keyword baru. New term that you might not come across before. You come across but we never use the proper term. We always use delta H, betul? So just now we say delta H a lot. Exo, endo, exo, endo. So where is the exo, endo come from? When the product minus the reactant. In the other words, every single product and reactant, contoh, saya guna yang paling senang je, NaOH tambah HCl. So saya dapat NaCl plus H2O. Benda yang kamu sangat familiar, betul? So knowing that that is my product, alright? Knowing that that is my reactant. Agree? Okay. Ada orang buta colour apa-apa colour ke? Orang pegelap, I really have student, I come across student yang dia tak boleh nampak warna hijau dengan biru merah ke, saya tak ingat. So you need to let me know if any of you having that issue. Okay? Dan, okay, over here. Dan kita kata delta H adalah produk tolak reactant. Bermakna produk akan ada delta H produk. Betul? Dan delta H products ni datang dari mana? Datang daripada NaCl, datang daripada H2O. Agree? In the other words, NaCl akan ada H dia, H2O akan ada H dia. Betul? And that is what we call enthalpies. Alright? Enthalpy means is the measure of the heat content of a substance. Setiap orang ni kena ada H dia yang tersendiri. Setiap compound yang kamu guna in chemistry will have their own specific energy. Water akan ada energy dia. NaCl akan ada energy dia. Supaya tak kisah dia jadi produk atau reactant nanti, we can add the energy up. So when they are product, dua-dua H ni tambah akan jadi H of the product. Betul? Dia akan jadi jumlah untuk produk. Okay? Kat sini kita akan ada jumlah untuk reactant. Betul? Selesai yang tu? And cuba tengok dua bawah ni. Enthalpy of reaction and standard enthalpies of reaction. Apa beza dua ni? Rasa-rasa. Standard condition. Can anybody tell me what is standard condition? Okay, ayat saya memang bagi lain sebab saya nak ayat yang saya bagi lain tu kamu ada option of different ayat. Tapi kalau kamu baca enthalpy of reaction dulu yang atas is the difference between the enthalpy of the product and the enthalpy of the reactant. Dengan kata lain, betul tak kalau Miss Wong tulis macam ni? Delta H reaction tak ada not ya. Sama dengan delta H product minus delta H reactant. Kan? So dengan kata lain dia sebenarnya adalah delta H reaction. Betul? Kat bawah pula, the enthalpy change for a reaction. So, the enthalpy change of a reaction means apa? Product minus reactant. Sama, betul? Ayat je nampak lain, tapi benda yang sama. So, kat sini, it's actually the same thing, but it's right now delta H not. Tekan lama sikit pun tak boleh. God's sake. Dia tahu saya tak boleh tulis soft code. Okay. The difference is the not and the word standard. And what makes it different on the standard is the standard condition that your friend said. And everybody should know standard condition. Keadaan dia adalah 298 Kelvin or 25 degrees Celsius and 1 atm. Semua orang standard condition. Yeah, correct. Betul tak nota kamu? Yeah, correct. Yes, correct. Okay. Standard condition. Kena ingat kat sini standard condition bukan standard temperature and pressure. Standard temperature and pressure STP adalah 0 degree Celsius, betul? Yang tu adalah STP. Kat sini adalah standard condition for enthalpies. 298 Kelvin 1 atm adalah standard enthalpies. Kalau yang bawah adalah at 25 degree Celsius 1 atm. Yang kedua at any temperature that is not 25 degrees Celsius and not 1 atm. Okay? Kalau benda tu tak berlaku pada suhu ini dan juga pada pressure ini, dan kita akan panggil dia enthalpies of fraction. Kalau benda tu berlaku pada 298 Kelvin and 1 atm, benda tu kita panggil standard enthalpies of fraction. Faham? Penting ya? Sebab definition akan mengubah. Okay. Question? Tak ada Next. What is the difference between chemical equation and thermochemical equation? Delta H, your friend down here say. Delta H, contoh yang paling senang Kalau saya ada chemical equation standard dissociation of water. Okay, if I dissociate the water over here. Alright, that is my chemical equation. Okay, standard lah, betul. What is thermochemical equation? Exactly the same thing, tapi kena ada something else. What is that? Delta H. So, delta H kena duduk di belakang. Okay? Delta H kena duduk di belakang with the value or whatsoever. Kalau soalan tu minta kamu tulis thermochemical equation sebagai soalan pertama. First question, thermochemical equation. Tak kira lagi pun, tak ada delta H. So, kamu nak letak apa? Delta H negative or positive like what I write. Thermochemical equation, kamu mesti kena ada indication of the delta H. Make sense? Boleh? And sayang, siapa makan lebih? Siapa makan lebih? Siapa akan dapat makan lebih? Thermochemical equation. Delta H kalau tak tulis, akan hilang satu markah. Alright? So we are now moving even, you are upgrading yourself, ladies and gentlemen. You are upgrading yourself. We are no longer stopped by chemical equation. Last semester kita insist dua benda. Balance, fasa. Betul? Balance tu kamu insist daripada home 5 lagi lah. So dulu kamu belajar kena balance je. Masuk kat sini SEM 1 kita nak kena ada fasa. Masuk kat sini kamu kena ada delta H. Make sense? Alright. And kena hafal. Duka citanya. Okay, it's easy, don't worry. Let's see. Bukan kena hafal je tau. Kamu kena faham equation kat bawah, kamu kena boleh tulis equation kat bawah. Okay, we go one only. Okay, tengok Tengok, ada soalan boleh tanya. The standard enthalpy of formation, simbol dia delta H not F. That is delta standard enthalpy of formation. Kita tengok sikit. The heat change. Alright. Heat change maksud apa? Bila dia adalah heat change, bermakna delta H dia boleh jadi positif, delta H dia boleh jadi negatif. Heat change bermakna dia boleh jadi heat absorb atau heat release. Pertama. Kedua, when 1 mole of a compound is formed from its element in a standard condition. Kenapa standard condition? Because it's a standard enthalpy. So dia kena duduk pada standard condition. Okay? So the keyword is 1 mole of compound is formed from its element. So 1 mole kena duduk kat mana? Product kena forever 1 mole. 1 mole of compound is formed from its element. Siapa 1 mole tu sekarang? Okay? So product mesti 1 mole dan bila kamu balance equation, dulu kita balance, janji balance lah betul. Kamu letak je nombor kan? Kat sini tak boleh. 1 mole akan memainkan peranan. Siapa 1 mole kita? Tak percaya? Tak payah salin dulu ya. Tak percaya kita tengok. Alright. 1 mole. Nampak? 1 mole. 1 mole sekarang duduk pada siapa je? Nampak? Every single one is having one thing. 1 mole. Nampak? So, bila kamu baca, kamu kena tahu satu benda. 1 mole duduk kat siapa? So, ada 3 benda yang kamu kena hafal dalam every enthalpies. Kita tengok balik Saya nak kamu baca dulu. Then you tell me what they said. Okay? Ada 3 benda. Benda pertama, heat adalah heat change, heat release atau heat absorb. Tak percaya kita tengok. Yang tadi dah ada heat change kan? So, sekarang pun ada heat change. Okay? Lepas tu, heat release means apa? Negatif lah, betul? Positif, betul? Nampak dah? So, bila kamu baca, jangan hafal babi buta macam tu Bila nak pandai. Okay? Bila kamu baca, break it down to 3 parts. First part, heat adalah change, release atau absorb. Okay? Yang tu. Yang kedua, cari siapa 1 mole. 1 mole kena duduk pada siapa? Yang ni sangat-sangat penting. Dua-dua ni sangat penting. Sebab dia akan menentukan delta H kamu positif atau negatif dan dia akan menentukan balance equation kamu dapat markah tak. 1 mole kena duduk kat siapa? Sekarang kamu tak boleh balance ikut suka hati aku lah, aku nak letak berapa mole, tak boleh. Kamu kena baca 1 mole tu duduk pada siapa. Make sense? Dan yang ketiga, standard atau tak standard? Yang ketiga, saya yakin kamu nampak. Standard enthalpy, standard lah adalah conditionnya. Tak ada, tak standard lah. Tak standard, belakang tu tak adalah 298, 1 atm nampak? Yang tu tak ada isu, yang tu senang. Tapi 2 kat depan tu. Okay? 2 kat depan tu. Make sense? Okay? And bila kamu baca, break it down to this, highlight this thing. Okay? Yang tu satu lah. You memorize the sentence. Yang kedua, you need to memorize. Not this one. I don't like to use the word memorize ever. Saya ambil je lah mana-mana enthalpy ya. Alright, whatever that come on the screen. Kita tengok ni. Standard enthalpy of neutralization. Heat release. Nampak tak? Delta H forever negative. Okay? 1 mole of water. Perasan tak? Dalam equation saya, water saya semua 1 mole. Dengan kata lain, bila kamu balance equation, saya tak boleh balance ikutlah acid saya nak berapa, base saya nak berapa. Yang tu saya tak kisah. Tapi satu benda. Bila equation kamu balance, at the end of the day, water saya kena 1 mole. Okay? Sebab tu kamu akan dapat pecahan kat sini. Biasanya kita tak akan dapat pecahan, betul? Kita akan dapat 2, betul? Alright? Sekarang nampak tak sekarang? Okay? So 1 mole duduk kat water. Okay? So look at it. Neutralization is 1 mole of water formed from the neutralization of acid and base. Acid and base forming water. Look at it. Nampak? So equation tu datang dari mana? Equation tu datang daripada definition. And we use the equation for your 2.2, 2.3, 2.4. Bayangkan kamu tak boleh tulis equation yang betul. You're gone. Soalan bagi apa pun you're gone. Okay? Dan next and last thing before you study, tengok soalan ni. Okay, tengok equation ni. Apa yang beza kat equation? Last thing for today. Saya ada Na jadi Na. Yes, bayangkan kalau kamu tulis equation ni tapi tak letak fasa. Alright, logik lah equation ni. So, what is the most important thing when you study the equation rather than just the 1 mole and the balance? Yes. Semua equation yang saya bagi dalam nota ada fasa. Bayangkan soal enthalpy macam ni. Enthalpy macam ni, tak ada apa yang berubah sayang. Satu benda je ubah. Solid jadi gas. Betul. Even balance pun tak ubah apa. Nampak? Okay? And I want you to look into that. And we will come back next week talking about these 9 enthalpies and bring this 9 enthalpy into 2.2. Okay? Boleh? Alright, question? Saya akan tanya seorang-seorang ya. Kamu tak boleh buat. Alright, thank you and have a good day. I'll see you guys around. Oh, attendance. Saya nak definition, saya nak equation. Oh, saya tak apa apa dia orang itu? Sorry, lupa macam biasa. Okay. I'll put it in hopefully today. Line kat college hampa tahulah. Yeah. Sayang, kadang saya terlupa upload video ataupun nota kena bagi tahu. Dulu saya boleh upload cepat sebab kita work from home, line laju. Saya boleh habis dan saya upload terus. Habis kelas kat sini nak upload tu, 10 jam, hang tahulah macam mana line kita kan. Alright, so bagi tahu